Okay, boys and girls, welcome back to school. Here we go. We're going to start lesson 5-1, which is all about systems of equations. So we're going to be looking at two equations on a graph at the same time, and sometimes answering questions about their equations. Like here, we're not going to graph because it says right here, without graphing these equations, what conclusion can you make about the system? And what that means is they want to know how many solutions this system might have. Either none, or one, or an infinite number of solutions. So let's take a look at them and see what we can do algebraically with the equations. You can see that this one says y equals 1.1x minus 4. So the slope is 1.1 and the y-intercept is -4. Here the equation is 3y equals 3.3x minus 12. And you would think these are completely different equations. They must intersect in one point. But hang on, because what we're going to do is we're going to take the bottom equation. Since the coefficients are bigger, see 3 and 3.3, and even the constant 12 is bigger than all the numbers in the equation above. So what we're going to do is try to divide this equation, the bottom one, by some factor to reduce the size of those numbers and see if they compare to the numbers in the top equation. And what we notice is that 3 and 3.3 and 12 are all divisible by 3. So what we're going to do is we're going to divide this equation by 3 every term. So starting with 3y. Let's see what we get. 3 divided by 3 is 1y. So we just write down y. Okay, we're dividing by 3, and that's going to equal the new equation, y. And we take 3.3 and divide by 3, we get 1.1 x. We're dividing every term by 3. And then finally, we divide 12 by 3, and we get 4. So now, what we need to do is compare this equation to this equation. And now we can see that they are identical, which means what? Of course, this system will have infinitely many solutions. Hang on, let me make that. So we're going to mark choice A. The system has infinitely many solutions, same slopes and same y-intercepts. Okay, for the next question, it's basically the same idea. It says without graphing. Again, so we're just going to look at the equations algebraically and see if we can figure out if they have the same slopes or different slopes, and compare the y-intercepts. And again, we're going to decide whether the system has one solution, no solution, or infinitely many solutions. So let's see, this equation right here, 2y equals x minus 7, and then this equation, 6x minus 4y equals 14. So we have to kind of get them in the same, what would you say? Let's solve each equation for y. So we're going to take this equation, 2y equals x minus 7, and we're going to divide every term by 2, because that will make y equals the rest of the equation. So we're going to divide 2 by 2, and we're going to get 1. That's 1y. We're going to take the coefficient for x, and can you tell what that is? Yes, good, it's 1. That's right. So we're going to take the 1x and divide by 2, which is 1/2 x. And we're going to take the 7 and divide by 2, and you got it, that's 7/2. Now, we're going to take the other equation over here, which is 6x minus 4y, hope I have room here, equals 14. And we're going to divide by what? Well, the first thing we're going to do actually is we're going to subtract 6x from both sides of the equation. And when we do that, we realize that we get -4y equals -6x, I am running out of room, plus, hang on. Okay, better yet, I'm going to do it over here. So we're going to take 6x minus 4y equals 14, and we're going to subtract 6x from both sides. That gives us -4y equals -6x plus 14, right? Now we're going to divide every term by, you got it, -4, because that will give us 1y. So we divide -4 by -4, and that's 1y. Then we divide -6 by -4, and that's -6 over 4. And if you reduce that fraction, that's -3 over, actually that's positive 3 over 2x. And then we divide 14 by -4, and we get -14 over 4, which is 7 over 2. So let's compare this equation right here to this equation. And what do you notice? Do you notice that the slopes are different? We have +3/2 in this equation. We have +1/2 in that equation. That means that there is exactly what? You got it. One solution. All right, hopefully you're getting the hang of this. There's a similar question here. How many solutions does this system have? 0, none, or infinite. And so what we need to do is compare them by solving for y. So again, this is what it looks like. I'm going to split this evenly this time. And I'm going to take one equation, which is this one, x plus 2y equals 0. I'm going to solve for y. Then I'm going to take this one, the second equation, which is 10y y equals -5x. I'm going to solve that one for y. So this one, if I solve for y, I have to subtract x from both sides. And that gives me 2y equals -x. Oops. 1 second. 2y equals -x. And then I'll divide by 2 on both sides. Divide by 2, divide by 2. And y, because the 2's cancel, right? Y equals -1x over 2, which is -1/2 x. Now let's come over here and do the same thing. We're going to divide by 10, so we can solve for y. 10's cancel, and that leaves us with y, and that's what we're trying to get. And then if we divide 5 by, that's a 1, that's a 1, 0. Divide -5 by 10, that's -1/2 x. Now, are these equations exactly the same? Yes. So what does that mean? That means that there are infinitely many solutions because they're the same line. They lie right on top of each other. That means they intersect in an infinite number of points. Okay, this should be getting easier and easier. And again, this question is the same. Without graphing, decide whether the system of equations has one, no, or infinitely many solutions. So we have to solve each equation for y, and this time we're in luck because this one, oops, hang on. Like I was saying, this one, we're in luck because that one is solved for y, this one is solved for y. So all we have to do is compare the slopes and the y-intercepts. So we start by comparing the slopes, and that's right here. -6 and +6. Are they different? Yes. That means the lines are eventually going to cross somewhere, which means very easily, very simply, that there is going to be one solution. Done. Okay, stick with me, boys and girls. This question says challenge, and it does look at it. You see the system has big numbers in it, but it's really the same question, right? Decide if the system has one, no, or infinitely many solutions. So all we have to do is just kind of factor these numbers, kind of reduce them by dividing by the same number and get them smaller so we can compare them. And we're going to solve each equation for y. Again, always that's our plan. So let's split this space. Hopefully we can do it on two sides here. And let's see, if we go -27x plus 51y equals 162, and we're going to divide by, let's see, can we go 9? No. Can we go 3 maybe? Now, if we divide every number in that equation by 3, we're going to get -9x plus 17y equals 54. Let's try the other equation. 18x minus 34y equals -108. Okay, let's see what the greatest common factor would be if we think about it. Can we go 9 into all of those? No. Can we go 3? Yeah, I think we can go 3, so let's divide every number by 3 and we would get 6x. No, we can't go 3 because 34 isn't divisible by 3, so let's think about that one again. Can we divide by 2? Yes. So let's see. Divide every term by 2 and we get 9x minus 17y equals negative 54. Now, compare those two equations. They look the same except that all the signs are different. So what does that mean? That means that the slopes are going to be different and the y-intercepts are going to be different. Don't get confused. Just because the numbers are the same doesn't mean the equations are the same. The numbers and the signs all have to be the same. Okay? And even though we didn't solve for y, we can tell that if we, for example, added 9x to this equation on both sides, and then we subtracted 9x from both sides of this equation, that this 9x on the right hand side of the equation now is positive, but this one is negative. So we can see that the slopes are going to be different signs down the line. And so what does that mean, boys and girls? Well, how many solutions is this going to have? If the lines have different slopes, it means exactly one solution. Okay, let's try this one. A little different. It says you plant 2 flowers in a garden. The equations y equals 11.5x plus 21 and y equals 5.1x plus 21 model the heights y of the flowers in millimeters after x days. What does the y-intercept of each equation represent? That's the first question we're going to answer, and then in the second part we're going to answer, will the flowers ever be the same height? Okay, that means will the lines cross? So again, we're looking at a system. We have 2 equations. And we want, the first question says, what does the y-intercept of each equation represent? So we're looking at this number, positive 21, we're looking at this number, positive 21, and that means that that is how tall the flowers are when they're planted. So let's look down below and see if we have find a matching answer. The height of the flower when planted, boom, just like that. Okay, and the 11.5x, what does that mean? That means the rate at which it's going to grow. So you have one flower growing at the rate of 11.5 millimeters per day, that's this one, and this one is growing at 5.1 millimeters per day. Okay, now let's go on to the next question. Will the flowers ever be the same height? Well, we just saw that the flowers are the same height when they're planted. Right? This one is 21 millimeters, I keep saying that, and this one is 21 millimeters high. They are the same height, but then they grow at different rates. So after they're planted, they're never going to be the same height again, but they will be the same height when they're planted, and so we choose that one. They're not always going to be the same height, and they're not never going to be the same height. They were the same height when they're planted. Well, would you say you're kind of getting this? Let's try. Does this system have one solution, no solution, or infinitely many solutions, or an infinite number of solutions? Okay, so again, we have to solve each equation for y. So let's make 2 spaces. On one side, we're going to take 3x plus 2y equals 1. Other side, 15x plus 10y equals 7. Now solve for y. So on this side, it means subtract 3x and subtract 3x. And we get 2y equals negative 3x, let's put that first, plus 1. And then divide by 2, every term gets divided by 2, and so 2 by 2 is 1. That's 1y equals negative 3 over 2x plus 1 over 2. So every number got divided by 2. Now let's do this one. We have to subtract 15x from both sides. That's a little sloppy, but you know what I'm doing. So we get 10y equals negative 15x plus, that 7 is positive, okay? Now we're going to divide every number by 10. So 10 by 10 is 1. That's what we wanted, y, 1y. Equals negative 15 over 10 is negative 3 over 2 when we divide both numbers by 5. And that's plus 7 over 10, right? because we divided every number by 10. So again, 15 divided by 10 was 3 over 2, so that's where this comes from, 3 over 2. Oh, and we forgot the x right there. Okay. Compare the equations. Do they have the same slope? Check. Do you see where that is? We have -3/2 for the slope in this equation and -3/2 for the slope in that equation. So that means they're going to be at least parallel. But are they going to be the same line? Well, let's look at the y-intercepts for that. This one's going to cross the y-axis at 1/2. This one's going to cross at 7/10. So they're crossing the y-axis in different points, but they have the same slope, which means they're parallel. Which means, how many solutions does it have? You got it. There is no solution for parallel lines with the same slopes and different y-intercepts. Okay, boys and girls, I'm going to do one more with you just to help you out. I hope that you'll be getting the hang of this. We have two equations here. It's a system, and it says by inspecting, what can you determine about the solutions? So let's figure it out. We're going to split our space into two sections and try to tackle it that way. So we have 6y equals 14x plus 24. Okay, so all we have to do is divide everything by 6. So that means 1y equals 14 over 6, which is 7 over 3 if we divide every number by 2. And 24 divided by 6 is 4. So there's one equation solved for y. Here's the other one, 9y equals 21x plus 36. So let's divide every number by, can we do 9? No, 9 goes into 9 and 36, but not 21. How about 3? Let's try that. So divide every number by 3. Or we could do 9. Just to divide every number by 9. Let's try it. So that would make 1y equals 21 over 9x plus 36 over 9 is 4. Now, this slope is 7 over 3, and this slope is 21 over 9. They look different, but are they in fact the same? Because can I take 21 and 9 and divide both numbers by 3? The answer is yes. I can simplify the fraction, and so 21 divided by 3 is 7, and 9 divided by 3 is 3. And look at that. I do in fact have the same exact slope as the other side of the equation and same y-intercept, which means you can tell me now that these lines have infinite number of solutions.